Hello everyone, I'm Sri Karav and today I'll be talking about one of the most essential topics on Android development that are buttons and on-click events. These two components are the foundation of interactivity in Android apps. Whenever you click on a button in any app, whether to send a message or play a video or submit a form, you're triggering an on-click event behind the scenes. So let's dive and understand how this works step by step. So let us go into the buttons and on-click events in Android development. Buttons are most frequently used UI components in Android applications. They act as a primary means for users to interact with and control in an app features. When you tap a button, it triggers an on-click event which defines what the app should do in response. Together, a button and a on-click event make the app dynamic, interactive, and user-friendly. Without them, the app would just be a static interface with no real interaction. So let's go into what is a button. So what exactly is a button? In Android, a button is a standard clickable UI widget that that represents a single tap target when a user uses it, taps it, it triggers a specific function in an application. Buttons are defined in XML file, usually inside activity main.xml file. Some key properties you will always see are under text. Label under text is used to label the label displayed on the button and ID. ID is a unique identity that lets you to refer in the code. Android on click. It is an optional attribute that links the button directly to the method. In short, a button is designed to take input from the user and initiate a response, making it one of the simplest yet most powerful user interface elements. Now, let's move to the on-click event, the heart of the user interface interaction. Whenever a user taps a button, the system sends out a signal known as a on-click event. This event acts as a bridge between the what the user does and what the code performs. For example, when the button is tapped, it might display a toast message, opens another activity, or sends data to a server. That's how on-click event turns a simple tap into a meaningful interaction. So now here on-click event is a system signal dispatched when a user successfully taps on a interactive user element like a button. It is crucial bridge between user action and an application logic. Now it is event handling. This is a this event is a core part of an Android robot input event handling mechanism managing how user interactions and are processed. So now let us go into the on-click event. So user taps the button. So it there on-click event happens. Then after going to the Kotlin file, so there will be event handlers, which will be the some filters and some programs. Then after the code executes. These are the process of the on-click event. So why on-click events are so important? Because they are what makes an application interactive and response. So now let's break down it. They enable actions. User can perform tasks like submitting, navigating, or confirming. They drive app flow, determining what happens when a user takes an action. They may they make field response, giving instant feedbacks through animation stores or transitions. Without proper event handling, even the most beautiful app will feel lifeless. Now, let's look at the first method using the Android onClick attribute in XML. This is the simplest way to click a button directly to use the function in a code. Here's the XML file code layout line. So these are the some of the attributes of the. So in button there are ID which helps to define the unique identity of the attribute like for button. So these layout width and height are the attributes to define the size of the button. So we just now we discussed about the text. So text. So these texts are labeled on the button, so which displays a tap tap for toast. Now next we also discussed about on click. On click it shows message. So coming to the Java activity method in Java file we have the message public void show message. So in this we make toast dot make text. So we are displaying as make text this comma button click. So this is taking as a display toast message. This method is great for quick prototype or small apps. It's extremely easy to set up, but it can get messy when you have many buttons in one activity. So while it's simple, it's not always scalable. Now, the second method and one of the most commonly used method is through using on set on click listener. Now, implementation is Java. Button BT, BTN click. This is a button where there is the name of the variable variable. So here find view by ID, which helps to define the identify the unique name of the button. So here BTN underscore click is an ID that is which we defined in the XML file. So next coming to the button click dot set on click listener. So this helps to identify and helps to understand the activity. Set on click listener. Set on click listener means when we tap on the button, so the activity, so the interact activity should start. So here we depend. No, it need to override. So it need to display tools dot make test main activity dot this listener activated. So this information is will be displayed. Now this approach makes your XML code separate from your event logic, which is Java or Kotlin. It gives developers much more flexible and control. You can add many conditions and complex logic or even trigger animations all inside the listener. That's why it is called industrial standard for handling click events. So now let's going to the third method. It is a cleaner and more organized approach implementing the View.OnClickListener interface. The the third method is clear and more organized approach implementing the View.OnClickListener interface. Here, your activity or fragment itself becomes the click listener. For example, coming to the code, so here we can see view dot on click listener. So here's your activity or fragment itself become the click listener. For example, this is the activity implementation in the Java or Kotlin file. So this method is excellent when you have multiple buttons. It keeps your code organized, reusable, and easy to mention, which deals for larger projects. Now let's understand the workflow of an on-click event, how everything happens behind the scenes. So now, step one, the user taps a button. User action required. This is the user tap button. Step two, Android system detects the interaction and recognizes it as click on click listener. Step three, the system links the event to the code depending on whether you used XML, listener, or any interface. Step 4. The handler executes runs the code defined by the developer. Step 5. The user receives feedback like a toast, message, or a screen change. For example, if you tap a button labeled show message, the system calls on click listener on click and displays the button click on the screen. That's the entire life cycle of a button from the user action to respond to app response. So, what's the main advantages of on-click handling? It is easy to integrate. Just define a button and connect it. It creates a response user experience, giving immediate feedback. It's flexible. Choose XML listener or interface depending on the app, and it promotes clean, reusable code, especially when using interface. Together, they make on-click handling one of the most powerful tools in Android UI development.
Now I'll be explaining my project, a simple calculator application built using button sign on click events. This project demonstrates how to take user input, perform basic arithmetic operations and display the result instantly using on-click event handling. The above app allows us the user to enter two numbers and then choose the operations such as addition, subtraction, multiplication, division by clicking the corresponding buttons. When a button is clicked, an on-click event triggers which calls a function Kotlin to calculate and show them the results. Through this project, I have implemented the concept of event-driven programming where user actions like buttons click control the program flow. Now, let us go to the code step by step. So this is an XML file layout that defines the user interface of the calculator. I have used here linear layout with vertical oriented, so all elements appears once below. Let us look into each header. At the top, I have a text view that displays the text. Enter the value. It is centric and bold to make it stand out. Edit text. Next, there are two edit text fields where user enters the numbers. The first one is et e first number and the second one is et second number, both having the input type number decimal and only accepts the numeric input. Next, instruction text view. I have added another text view saying the select the mathematical operation which tells us to user what to do next. Coming to the buttons, here we have four buttons for addition, subtraction, multiplication, and division. Each button has a unique ID like btn add, btn add, btn subtract, btn multiply, btn divide. These IDs helps us to connect each button with this logic in the Kotlin file. Then finally, result text view. Finally, at the bottom we have the text view with the ID TV results. This is where the output or the result of the calculation will be displayed. So this is an XML file which defines the structure and appearance of the calculator interface. But the real functionality, what happens when we click the buttons, is written in the Kotlin file. Now let's move to the Kotlin file main activity.kt. This file contains the logic and the functionality of our calculator. Here we need to follow some steps. Some steps. Step 1, declaring variables. At the top I have declared the variables for all user interface, edit text, buttons and the text result. I have used late init var, which means these variables will be initialized later in the onCreate function. Next, linking the XML components. Inside the onCreate method, after set view content r.layout.activity main, I have used find view by id to connect each variable with the component from the XML file. For example, et first button equals to find view by id r.id.et first number. Links the first edit text from the layout to our Kotlin variable. This process allows our Kotlin to interact with the layout. Now, step 3, setting button on click listeners. Next, I have set on click listeners for each button. When a button is clicked, the listener triggers a specific function. Here, clicking the add button called the calculate function and passes the symbol place as an argument. Similarly, the subtract, multiplication, and the division passes their respective. This is a great example of using setOnClickListener, which is recommended method to buttons handle button clicks in Android. Now, in the step 4, let us look into the main function calculate. This function performs the required mathematical operations based on which button was clicked. The user need to provide the inputs from the edit text fields and convert them into numbers using true, double or null. This function safely converts text to numbers and returns null if the input were invalid, which helps preventing app crashes. then if if condition to check whether the numbers are valid, if yes, when condition statement to perform, and when condition statement to perform the correct operation depending on the operation symbol passed. For addition, it adds the two numbers. For subtraction, it subtracts, and so on. If the user tries to divide by 0, it shows an error message instead of crashing. Finally, the result is displayed in the TV result text view. Now let us run the program. No, these enter first number, enter second number. These two are the edit text numbers. So I am giving, let us for example, for first number 6, for the second number 3. So then after we have the four buttons, which are addition, subtraction, multiplication and division. On clicking on each button, so their result will be displayed in the bottom. So for the addition, the result is 9. For the subtraction, the result is 3. For the multiplication, the result is 18.0. For division, 2. So if I provide the second digit as 0, if while I am trying to divide, the result will be error, division by 0. This is an example for a simple calculator using the button on click listener.
Now let's quickly summarize what we have learned today. Buttons and on-click events are the core Android interactivity. They make app functional, responsive, and user-driven. We explored three ways to handle button clicks: using the XML attribute, using setOnClickListener, and implementing the View.OnClickListener interface. Using the right method depends on your app complexity. For smaller apps, use XML files. For scalable maintenance apps, go with the listeners or interfaces. Mastering these event handlers techniques help you transition from building basic demos and developing real-world Android application that users love. That brings us to the end of the today's session on buttons on click listeners in Android. I hope this session helped you to clearly understand how buttons interactions are handled in Android development. If you found this helpful, make sure like, share, subscribe. Thank you.